In this video, I'm going to be showing you how to put together a neural network that learns to recognize hand-drawn digits. Now, when watching this video, please understand that I'm not an expert. I don't have calculus knowledge, which is kind of the backbone behind some of the functionality in this network. So what I'm saying is don't expect this video to go too in-depth on some of the more complex topics. Rather, just expect this video to be more about putting the pieces together. So this video is geared more towards people that kind of want to get something made rather than understand it at a deeper level. But if you do want to understand it at a deeper level, I can link some videos in the description for that too. To start us off, we're going to have 6 imports. Import random for generating random weights and biases at the beginning of training. From pill, import image. This is for using the image function where we can open images or just retrieve image data. And then import numpy as np. This is for creating arrays with the image data. Import os. This is for being able to access and get the images in our folder. And then import math. This is for being able to run math functions. For example, we had to make a function that was called def sigmoid, where we have to use the math function there. But I think that's the only time I had to use it. Then import JSON. This is for saving and loading the weights and biases when we're done training. Now for the second thing we're going to need, it's going to be the amount of neurons per layer, and then we're also going to throw in the learning rate with this category. So 400 would be representing the amount of pixels for image, so I went with 20 by 20 pixels. Then I went 16, 16, and then 10, but there's not really like an exact number you need for this, and I believe you can change this flexibly, just not this 10, because you need 10 for representing each number. Now here's where we actually get some of the functionality. This is us initializing our weights and biases. It's one weight from each neuron to each neuron in the layer after it. So a total of, actually I'm not going to calculate that, but you get the idea. Then there's one bias for every single neuron in the layers, not including the input layer. Now we're going to be inputting the functions used for saving and loading our weights and biases. And these are the 2 functions that are used for loading our data set. And also this has to be whatever the folder's name is that you're storing all of your data in, and the data folder, or whatever you choose to call it, will have to have 10 subfolders, each titled 1 through 10. And if you do not have that, you can change each of these things right here to fit your needs. But that's what this base function has. You need to have a file set up similar to mine here, where you have all of your numbers inside of this one called data. We're going to go ahead and add the sigmoid function, though we won't use it till a little bit later. And we're going to create this dataset variable and load the dataset into that. We're not going to have load run the first time, as we won't have anything to load. And then we're going to add the print guesses function. While this is optional, I prefer to have this in my my main loop, just so that I can see how the model gets more and more accurate over time and guesses more accurately, I guess is what I should have said. But yeah, it is 100% optional, though I didn't have any other way of seeing any progress for the model. This is the main loop for training the model. I called it run, and this is basically where all the magic happens. I'm not going to get into really any depth on how this works, but I can for sure link some videos in the description about how this works. Maybe in a future video I'll explain it all, but for now I don't entirely understand it, but I also don't think I do a very good job at understanding, explaining what I do understand. We can also just add a for loop down here, and then we can just call the function run. And there we go. We will run through all of our data that we have stored in our data folder 1,000 times, and then over time it will keep printing using the print guesses function that we added earlier. And you can watch your model get more and more accurate, and if you want to, you can also add some of your own personalized data. 20 by 20, I recommend using Pixelorama for I guess ease of exporting in large amounts of images, though I'm sure there's some other software that's also good at that, but that's just what I personally used. You can use white and black pixels only, although actually you might be able to use any range, though we'll probably give decimal points rather than just ones and zeros when creating the array. However, I just use black and white, so that's what I know works for sure, no promises. But yeah, as of right now, this is a fully functional model. I'll show how this other one works, though I already trained it a little bit, so it's going to be accurate from the start. But you can kind of just see how some of its predictions, like you can see it was like a bunch of 5s. But it takes a while, but at the end of this training process, I will show all of how it's accurate and whatnot. Now my training has completed, and you'll see that it is extremely accurate from where it was, but I'm sure if we ran it for a couple hundred more times than just 100, it will get more and more accurate. You can see there's some instances where it gets it wrong, although it is really accurate for the most part. And a lot of that has to come down with your quality of data. You're trying to cover as much of a range of different instances as possible. Though I only had 100 or so, but it is also just training off of the same data and predicting off the same data, so you'll see a higher accuracy in that. Although I wish I could have covered a lot more in the on how complicated all of this is. Maybe in a future video I'll explain more of the complicated topics, but for now, this is how to make a neural network that recognizes handwritten numbers and makes predictions and learns based off of how wrong it was. Thank you for watching.